This video has been put together as a revision activity and a teaching activity about balancing chemical equations, specifically focusing on one of the most challenging and most important types of balancing equations when you've been given the reactants, but you've been expected to write your own equation and balance that equation. And one of the reasons this is so challenging is particularly if you haven't picked up on the fact there's a system of steps, a system of logical steps in a logical sequence to take you through this process of writing the equation and balancing the equation. And it incorporates a whole lot of skills we've learnt so far in the course, including writing formulae, writing equations, and obviously balancing the equations. And these 6 reactions on the left are the 6 we're going to be focusing on as we go through this activity. The first thing in the sequence of steps is to realise you need to know what sort of reaction it is. And the types of reaction you might be asked to balance are metal acid, where you need to know that the reaction is metal plus acid goes salt plus hydrogen, acid plus base goes to salt plus water, otherwise known as neutralisation, and acid plus carbonate goes to salt plus water plus carbon dioxide. But in order to do this, you need to understand what a metal, acid and base are, and also what a carbonate is. It's expected you to know what a metal is at this stage of the course and also what a carbonate is, but the 3 acids you need to know are these 3 here, hydrochloric, sulfuric, nitric. You need to know their names and their formulae. As far as a base is concerned, metal oxides and metal hydroxides are the sort of bases you need to understand in this stage of the course. So you need to figure out what type of reaction it is. The next thing is you need to write the formulae of the reactants. If you've been given the names of the reactants as just names without formulae, you have to write the formulae. And that means you need to use the cross method if it's an ionic compound. You can't just ignore those skills you've learned, you have to apply those skills. Once you've got the formulae for the reactants, you need to figure out what the products are, and I strongly recommend you write them down as a word equation, so finish the word equation. Once you've got the word equation done, you then use the cross method again to determine the formula of any salt in the products. And salt is just the name given to ionic compounds. And you know how to write the formula of ionic compounds using the cross method. Once you've got all the formulae correct, then you can balance the equation. And the sequence we've been learning about is the fact you use polyatomic ions first, followed by metals, all the other things in the equation, then carbon, then hydrogen, and oxygen last. And the last thing you do is check states. We're going to leave that right to the end of this video because I want to focus on the logical sequence as opposed to states. But in general, the states, metals are typically solids. All those diatomic gases on the periodic table are gases, obviously. Water is a liquid. Acids are always aqueous. Ionic compounds are salts. If they're in the reactants, they're usually a solid. If they're in the products, though, if it was a water or acid reaction, they're usually aqueous in the products. In Year 12, you'll need to learn when sometimes they're solids as well. So let's look at balancing some of these equations. The first one we're looking at is lithium plus sulfuric acid, and the first thing we'll do is figure out what sort of reaction it is. Well, clearly we've got lithium and sulfuric acid, and if I just change this to a pen, we have lithium and sulfuric acid. Clearly it is a metal and an acid, so it's one of these sort of reactions. Metal plus acid goes to salt plus hydrogen. And we know it's an acid because sulfuric acid is one of our acids here, and I'm going to keep this up here as a reminder for the rest of this slideshow. So we know it's going to be lithium and sulfuric acids. The first thing I'm going to do here is write down my metal and my acid formulae as the next step in our process. And I need to start thinking about, well, what products is it going to make? Well, I know metal plus acid goes to salt plus hydrogen. And if I look at these reactants here, the only place hydrogen appears is here in the sulfuric acids. That's where the hydrogen is coming from. When that hydrogen disappears to become hydrogen gas, all that's left is lithium and sulfate, which suggests to me that the salt I'm going to make, this salt here, is going to be lithium sulfate. So I can put that in there now. I know that the word equation will be lithium plus sulfuric acid goes lithium sulfate plus hydrogen. The next step now is to figure out the formulae of these products over here, particularly the formula of lithium sulfate, because that's my ionic compound. I've got to use the cross method to figure out its formula. I can't just write it down. So using the cross method, I'll write down both species and their respective charges. Lithium with a charge of +1, sulfate with a charge of -2. I then write them down again and I cross over the valencies. The 2 from the sulfate comes in here next to lithium. The 1 from lithium comes in here next to sulfate. I know I don't write the 1s, so my final formula of lithium sulfate, using the cross method so I know that formula is correct, is Li2SO4. I can now go through and finish off that equation by putting the correct formula in. So now I can put lithium sulfate up here. I know it's the correct formula for lithium sulfate. I know hydrogen is a diatomic gas, so I'll put them in. So now I'm sure I've got all the formula of all the particular chemicals in this reaction correct. The last step now is balancing. And when I balance, this is the order I go through. Polyatomic ions, metals, everything else, and then carbon, then hydrogen, then oxygen. So the first thing here, the polyatomic ion, is sulfate in my equation. So looking at sulfate, I've got 1 sulfate in the reactants and 1 sulfate in the products. I balance it as a whole polyatomic ion, and it's balanced. And this thing here, this little 3 on the side of it here, I'm not sure why it's a 3, it should have been a tick. It looks like all those fonts have been changed, so just assume that those 3s are now ticks. We have balanced the polyatomic ions. The next thing to look at is lithium. Lithium's not so easy. I have 1 lithium over here in the reactants, and I've got 2 lithiums here in the products. That is not balanced. The way to fix that, I need to make sure there's 2 lithiums over here. I can't put a little 2 subscript. That's ridiculous. I've got to make sure there's 2 lithium atoms on this side. So that's how I balance that. So now I've got 2 lithiums in the reactants. I've got 2 lithiums in the products. Lithium is now balanced. And we can move on to the next thing. That little tick there again is not a 3, it's a tick. Just get that in your minds. The next thing, other, there is no other elements apart from hydrogen there, so we're coming right down here to hydrogen. And looking at the hydrogens, I've got 2 hydrogens in the reactants, I've got 2 hydrogens in the products. Hydrogen is balanced. That means every element in my reaction is balanced, and that means that equation is balanced. We'll put that in green, we'll lock that in. On to the next one, magnesium plus nitric acid. For me, I've got a metal and an acid. So once again, it's metal plus acid goes to salt plus hydrogen. My first step is to write down the formulae of these particular things. Mg is just an element Mg, and nitric acid HNO3 is one of those acids I have to know the names of. The next step in the logical sequence is to write down the word equation, complete the word equation. So metal plus acid goes salt plus hydrogen. Once again, the hydrogen comes from here. What's left when the hydrogen goes away? The salt will be made of magnesium and nitrate, so that tells me the salt will be magnesium nitrate plus the hydrogen gas I produce. Next step in the logical sequence is to figure out the formulae of everything in my products. The most tricky one here is the magnesium nitrate. That's the salt or the ionic compound. I have to use the cross method. So once again, I write down the formulae. Magnesium's got a charge of 2+, nitrate's got a charge of -1. I cross those valencies over, it becomes Mg1 NO32. I know I don't write the 1s, and also with the 2, I've got to be very careful. It looks like MgNO32. We know that's wrong. What this 2 here is representing the fact that I have 2 nitrate polyatomic ions, and that means I need to specify somehow this 2 corresponds to being 2 nitrates, not just an extra 2 next to the oxygen. So I have to put the brackets around the magnesium nitrate or the nitrate component to show there's 1 magnesium atom and 2 nitrates, or sorry, 1 magnesium ion and 2 nitrates in every unit of magnesium nitrate. So now I know that, I can put that into my formula. I know the formulas of my salt here is MgNO32. I know hydrogen's diatomic gas. That comes into H2. The next step is the balancing. Once again, polyatomic ions first. I've got nitrate in both the products and reactants, but unlike last time, this time it's a little bit different. I've got 1 nitrate in the reactants and 2 nitrates in the products. That means I need to balance my polyatomic ions. I can't suddenly just change the formula of nitric acid. We can't do that. All we can do is make there be 2 nitric acid molecules by putting a 2 at the front. That prefix 2 says there's 2 nitric acid molecules. Now I've got 2 nitrates on both sides. That means the polyatomic ions are balanced. Moving on to the metals, I've got magnesium. I've got 1 magnesium on both sides, so magnesium is balanced. There's no other elements there apart from hydrogen. Come down to the hydrogen. I recognize that 2H here, and there's no little subscript here, which means there's just 1 hydrogen atom in each nitric acid. There are 2 nitric acids. Overall, I've got 2 hydrogens on the reactant side, and I've got 2 hydrogens on the product side. Hydrogen is also balanced. That means every element is balanced. That means that equation is now balanced. Moving on to our third example. Once again, it's a metal acid example. If you're watching this video, it might be a good chance now to try out this technique. You can pause the video and then test yourself at the end to see how you're going with this particular one. Otherwise, you can keep listening on. It's a metal plus acid, sodium plus sulfuric acid. I know the formula of sulfuric acid. I can put that straight there. I know the formula of sodium from the periodic table. It's Na. I know it's going to form a salt plus hydrogen. How do I know it's going to be sodium sulfate and hydrogen? Well, because it says metal plus acid goes salt plus hydrogen, obviously hydrogen is going to be there. If I take the hydrogen out of the reactants, all that's left is sodium and sulfate, which tells me the salt was going to be produced had to be made of sodium and sulfate, otherwise known as sodium sulfate. I've now got to figure out the formulae of that sodium sulfate using the cross method. I've got sodium have a valency of 1, sulfate have a valency of 2. I cross them over, I get Na2SO41. We obviously don't write the 1s, so the formula of sodium sulfate is Na2SO4. I can put that now into my equation. So I know now that all the formulae in my equation are correct, which means I can move on to the next step, which is actually balancing that equation. Once again, look at polyatomic ions first. I have a sulfate in the reactants and 1 sulfate in the products. That means sulfate is balanced. I can move on to the next thing, metals. I've got 1 sodium in the reactants, but I've got 2 in the products. That tells me I need somehow to make 2 sodiums in the reactants. Easiest way is to put a 2 at the front. I've got 2 sodium atoms reacting. Now the metals are balanced as well. There are no others. All that's left is carbon, hydrogen, oxygen. And once again, I've got 2 hydrogens in the reactants, 2 hydrogens in the products, hydrogen is balanced, every element's balanced. That means that equation is now balanced. So far we've done that review. The first thing we do is figure out what sort of reaction it is. We complete the word equation. We write down the formulae of the things in the reactants. We then write down the formulae of the things in the products, making sure we use that cross method to make sure the formula is correct. Once we're sure all the formulae in the whole equation is correct, then we can balance that equation by making sure we've got the same number of atoms or same number of ions in the reactants and the products. Moving on to our fourth example. Once again, this is another metal plus acid reaction. This time it's calcium plus hydrochloric acid. Once again, to test yourself, you should probably pause the video here, have a go at writing out and balancing this equation before you listen to the next bit or before you skip forward to the answer. So pause it now and have a turn at this particular reaction. Okay, going through the steps, we write down the formula of the things in the reactants. Calcium is just calcium atom, Ca. Hydrochloric acid is HCl. I look up here, it's metal plus acid, it's going to form salt plus hydrogen. If I take out the hydrogen from my reactants, all that's left is calcium and chlorine, which tells me the salt produced, the ionic compound produced, is going to be calcium chloride. So I can write it in that turns into calcium chloride plus hydrogen. I can then use the cross method to figure out the formula of calcium chloride. Calcium's valency is 2, chlorine is -1. I can cross them over. I get Ca1Cl2. We know we don't write the ones, so the formula of calcium chloride is just CaCl2. I can put that now into my reaction, so I know all the formula of all the species are correct. The next step is balancing. Polyatomic ions first, metals, other, then carbon, hydrogen, oxygen. There's actually no polyatomic ions in this one, so I can go straight to the next thing, metals. I have 1 calcium on both sides, metals are balanced. I come down to other, this time we've got another one, it's chlorine. Chlorine, I've got 1 chlorine in the reactants over here, I've got 2 chlorines in the products, that means they're not balanced. That means I have to have 2 hydrochloric acid molecules to get those 2 chlorines in the reactants. Now I have 2 chlorines on both sides, that is balanced. The last thing left is hydrogen. I have 2 hydrogens in the reactants here, I've got 2 hydrogens in the products, hydrogen is also balanced, every element's balanced, the equation is balanced. This time we're looking at a different sort of reaction. This is a copper 2 hydroxide plus hydrochloric acid reaction. It is no longer a metal plus acid reaction. This time I've got copper 2 hydroxide. Looking up here in this blue section up here, I can see that copper 2 hydroxide is a metal hydroxide. It is therefore a base. I've also got hydrochloric acid. Clearly that's an acid. So this sort of reaction is a new one. This one's an acid plus base or a neutralization reaction. The products this time will be salt plus water as opposed to salt plus hydrogen. So now I know what sort of reaction it is, I can start looking at the actual solving of this problem. First thing, I have to figure out the formula of the things in the reactants. Now previously I've all been dealing with metals, calcium, sodium, magnesium, lithium. This time though, one of the reactants is actually an ionic compound. Because it's an ionic compound, I have to use the cross method to figure out the formula. I can't just write down Cu and OH and hope for the best. It says copper 2 hydroxide. That means I know the valency of copper in this particular chemical is copper 2+. I know the valency of hydroxide ions are -1, I therefore can cross them over, and the formula of this becomes CuOH2, but I can't forget the brackets because it's a polyatomic ion with multiple polyatomic ions, so the formula of copper 2 hydroxide is CuOH2. I can get the formula of hydrochloric acid straight from the list up here, and therefore I can write down the formula of both things in my reactants, copper 2 hydroxide plus hydrochloric acid. I know it's going to form a salt plus water as we said before. Looking down here at these chemicals, I've got oxygen and hydrogen in this reactant here, I've got hydrogen in this reactant here, they're going to form the water. All that's left is copper ions and chloride ions. And don't forget, because this is copper 2 hydroxide, these ions here, these copper ions here, they'll be copper 2 ions. So when I go to figure out the actual chemicals in my products, I've got to remember that. And acid plus base goes salt plus water. The water is pretty obvious. The water comes, as I said before, from the hydroxide ions and the hydrogen. All that's left is the copper and chloride. That means it's going to be copper 2 chloride. Now we've got to figure out the formula of copper 2 chloride. Copper 2+, as we said before, chlorine's -1. I cross them over. The formula for copper 2 chloride is CuCl2. So now I can put both those chemicals into my products. Copper 2 hydroxide plus hydrochloric acid goes to copper 2 chloride plus water. Next comes the balancing steps. Polyatomic ions, metals, other, carbon, hydrogen, oxygen. Now I do have a polyatomic ion in this formula. Over here I've got hydroxide. It's a polyatomic ion, but if you look across into the products, hydroxide ions don't appear anywhere. And that means I can't balance polyatomic ions because you can only do that step if the polyatomic ion appears both in the reactants and the products. So I've got to go straight to my metal step instead. I've got 1 copper in my reactants, I've got 1 copper in my products, metals are balanced. I can go to other now. The other thing will be chlorine. There is 1 chlorine in the reactants in this hydrochloric acid molecule, but there are 2 chlorines in the copper 2 chloride. Therefore, that needs to be balanced. I need to put 2 chlorines somehow in the reactants. The way to do that is to make 2 hydrochloric acid molecules. Now I've got 2 chlorines in the reactants, 2 in the products, other, or chlorine is now balanced. Then I do carbon, hydrogen, oxygen. The first one I look at is hydrogen. Over here, I have got two hydrogens. Because there's a hydroxide ion, there are 2 hydroxide ions. There are therefore 2 hydrogens overall. I've got 2 hydrogens in the hydrochloric acid. And what this little bracket thing here is, that means in the reactants altogether, I had 2 hydrogens in the hydroxide. Over here, the copper 2 hydroxide, I've got 2 hydrogens in the hydrochloric acid. There are 4 in total hydrogens in the reactants. In my products, though, I've only got 2 hydrogens and 2 in the 1 water molecule. That means I need to balance that. That means I need to have 2 water molecules in the products to make 4 hydrogens overall in the products and 4 hydrogens overall in the reactants. Now my hydrogen is balanced. The last thing to look at is oxygen. Where is the oxygen in my formula? I've got 2 oxygens, 2 of them in the hydroxide ion over here. I've also got 2 oxygens because I've got 2 water molecules in the products. That means oxygen's already balanced. That whole equation is now balanced. Moving on to the last one, aluminium carbonate plus sulfuric acid. Once again, if you want to have a go at this yourself, pause the video, have a go, and then check your answers at the end. Aluminium carbonate plus sulfuric acid, what sort of reaction is this? Well, it's acid plus carbonate goes to salt plus water plus carbon dioxide, as it shows up here. The first thing I've got to do is, because this reactant is not just a simple metal, it is an ionic compound itself, I've got to figure out its formula before I start. Aluminium is in group 3, it's got a charge of 3+, carbonate's got a charge of -2. I cross them over, I get quite complicated formula, Al2CO33. Obviously that's not supposed to be 33. I've got to put a bracket around the carbonate to show there's 3 carbonates. For every 2 aluminiums, there are 3 carbonate ions. Now I can put down my formulae of the reactants, aluminium carbonate and sulfuric acid. I said before it's acid plus carbonate goes to salt plus water plus carbon dioxide. Clearly, the water has to come from the hydrogens here and the oxygens here. The carbon dioxide also comes from the carbonate ion here. All that's left there is aluminium and sulfate. And therefore that salt I produce is going to be aluminium sulfate. So I can write that in. Goes to aluminium carbonate plus sulfuric acid, goes to aluminium sulfate, water and carbon dioxide. Once again, I've got an ionic compound or a salt in my products, therefore I've got to use the cross method to figure out its formula. Once again, aluminium's got a charge of 3+, that actually should say sulfate, obviously didn't change that when I was copying this through. Sulfate's got a charge of -2, let's get through that quickly. They should all be sulfates up here, I apologise for that, rather than carbonates, so I'm sure you can figure that out. But it turns out to be the very similar formula. It's Al2SO43. So putting that in with my known formulas of water and carbon dioxide, I now have all the correct formulas inside that particular equation. Next step comes the balancing. Once again, polyatomic ions, metal, other, carbon, hydrogen, oxygen. Now I've got 2 different polyatomic ions in this equation. I've got carbonates here and I've got sulfates here. But notice sulfates appear on both sides of the equation, whereas carbonates do not. We know that carbonate breaks down to form the carbon dioxide, therefore I can't balance carbonate as a polyatomic ion, but I can balance sulfate as a polyatomic ion. And looking here, I've got 1 sulfate in the reactant, so I've got 3 in the products. That obviously doesn't work. I need to have 3 sulfuric acid molecules to make 3 sulfates in the reactants, and therefore my polyatomic ions in regard to sulfate is balanced anyway. Next thing is the metals. I've got 2 aluminiums in my reactants, I've got 2 aluminiums in the products. Aluminium is already balanced. Other, let's look at other here. First of all, no, there's no others, there's carbon, hydrogen, oxygen left. So balance my carbons next. I've got 3 carbons in the reactants because I've actually got 3 carbonate ions. That means 3 carbons. I've only got 1 carbon in the products, so 1 carbon dioxide. That needs to change. I need to have 3 carbon dioxides in the products to balance my carbons. Now carbon's balanced. Next thing is hydrogen. Looking at hydrogen, I said I had 3 sulfuric acid molecules here. Each molecule's got 2 hydrogens. That means I had 6 hydrogen atoms in the reactants. I've only got 2 currently in the products. Therefore, I need to have 3 water molecules to make 3 sets of H2, which makes 6 hydrogen in the reactants, 6 hydrogen in the products. Hydrogen is now balanced. Looking at oxygen, last of all, I've already balanced the oxygens in the sulfate, so I can ignore those ones for now. These oxygens here were already balanced when the sulfate was balanced. The only oxygens that haven't been balanced are these ones in the carbonate here, these ones in the water, and these ones in the carbon dioxide. So I'm going to make sure these ones balance now. Looking here, I had 3 carbonate ions. That means 3 lots of 3 or 9 oxygens here. I said before I don't have to worry about those 2 because these ones have already been balanced when I balance the sulfate. I've currently got 3 from the water here, 3 water molecules. I've currently got 6 here, 3 lots of carbon dioxide makes 6 oxygens here. 3 plus 6 makes 9. Oxygens balanced on both sides. That equation is now balanced. But the one thing we haven't done yet is this thing called states. Metals are solids. You know these things are always gases, water's liquid, acids are always aqueous, that's something you've got to remember. Ionic compounds and the reactants, you can think of them as solids. If they're formed in the products, they're usually going to be aqueous, particularly if it was formed in a water or acid-based reaction, because they'll be dissolved in the water when it's made. They won't form as crystals. So knowing that, now's a good chance to go through and try and balance all these equations. We've already balanced them, but try and put the states in now. Use those rules about states to try and put the states in. Pause the video if you wish, and then you can check your answers in just a minute. Okay, let's have a look at what those answers were. With all the states in there, you can freeze the video and have a look at those states, but all the states are there. Notice all the metals here on the reactant side. If I can find my cursor, oh, there it is. All solids. The ionic compounds in the reactants are all solids. All the acids all the way through are aqueous all the way down, but all these salts I produced, because they're formed from an acid reaction, all these salts are going to be dissolved in the water. They're all aqueous. Water is always liquid, hydrogen is always a gas, and carbon dioxide obviously is a gas. And having gone through that video, you should be much better prepared to balance these equations where you have to write the equation yourself.